In this video, I explain condition for stability of submerged body. So what is meaning of stability? So when we apply certain force or angular displacement to the some body, and this bodies give some reactions or some displacement, and after the displacement it's come on its original position or not come its on original positions, or it is also possible that body is getting some new positions. Okay, so it is called as the stability. Now what is a submerged body? Means any body which is inside the fluid. The fluid means water or air. So suppose we have one balloon and balloon in the air, so we can say that the balloon is submerged in air. Now we have submarines and submarine is inside the water, so we can say the submarine is submerged in a water. So here we understand the meaning of stability and meaning of submerged body. So there is three conditions are there. One is called as the stable equilibriums, second is says the unstable equilibriums, and third one is saying the neutral equilibriums. So earlier I explained about the stability. When we apply some force or angular displacement to the body, there is a three possibilities are there. Either the body is returned on its original position, second possibility is that the body is sink inside the water or a fluids, and third body is getting the new positions. So these 3 point is applied to three theory, that is stable, unstable and neutral equilibriums. Now we can understand these 3 point in the detail. For understanding these 3 points, we need to focus on two important points. One is the center of gravity and second is the center of buoyancy. So when we study the buoyancy, the three important points are there. In a last theory of the metacentric height and the metacenter point, we studied a 3 point. One is the G point, that is the center of gravity. Second, we studied a B point, that is the point at which the buoyancy force is applied, and third is the metacenter point. Metacenter means it is a point about which the body is oscillating. So when we study about the submerged body, we need to focus on 2 points, center of gravity and the center of buoyancy. We not need to consider the metacentric point. So first we understand the stable equilibriums. For understanding the stable equilibrium, we consider a balloon which is completely submerged in a air. So submerged means it is submerged in air, or either it is submerged in a liquid or water. So here we see that this is the one balloon, and at the end of the balloon, for increasing weight or making it stable, here we add some additional weights onto the balloon. And in the balloon, here we see that this is the G point. G means center of gravity. Means at the G point, the whole weight of the balloon is concentrated. It is called as the point G, and the weight of the balloon is concentrated at G point. So we know that the weight is always concentrated in downward directions. Okay, so here we draw the downward arrow, and this W is indicate the weight of the balloon. And this is the B point. B point means it is a point at which the buoyant force or buoyancy force is concentrated, and it is acting in a upper directions. So at the lower portion of the balloon contain heavy material, so that its center of gravity is lower than the center of buoyancy. So here we add certain weights. So due to that, the gravity point is below to the buoyancy force. So here we see that the G point is below to the point B. Let the weight of the balloon is W, which is acting through G in vertically downward directions, while the buoyant force FB is acting vertically up through this B point. And for the equilibrium conditions, both the forces, that is a weight as well as the buoyant force FB, must be equal. So here this W and FB is the same. Now if balloon is given the angular displacement in a clockwise direction as shown in this figure A. So in this figure here we see that the small angular displacement is given to the balloon in a clockwise directions. So at that time what happened? Then W and FB consists the couple acting in the anti-clockwise directions and bringing the balloon in a original positions. Thus the balloon in this position is in the stable equilibriums. Means when we applying the small angular displacement in clockwise directions, so balloon is reached to the new position. Here we see it is at the certain angles, and here we see this diagram, the both are acting in a one axis, but here the axis is changed. So here suppose we draw one vertical line, then cross lines, and then again these vertical lines. Okay, so when we apply certain force in this downward direction, what happen? Balloon is going or moving down in a clockwise directions. But here some couple is acting or some couple is created. So which couple is created? From here we see that the W is acting in downward direction. From this point to this point, this FB is trying to move in upper direction. So here one couple is acting and this couple is trying to move in a anti-clockwise direction. So balloon is coming to its original position, then it is called as the stable equilibriums. So here couple is this. Here you focus on this line, this vertical line, cross line, and this FB is upper direction, means they are try the movement in a anti-clockwise directions. So thus W and FB and the point B is above G, then the body is said to be in a stable equilibriums. So when the body is in stable equilibrium, first the W and FB is equal, then the buoyancy force is about the G force. Okay, so when the B is about to the G point, at that time this anti-clockwise couple is created and body is coming to this original positions. Now before moving ahead, I request to like the video and subscribe my channels for watching the more video about the FMHM as well as the other subject of mechanical engineering for FMHM. Various link is provided in descriptions as well as in card. Now second is the unstable equilibriums. So in a stable equilibrium, what we study, body is come its original position after giving some angular momentum. So first we apply some angular momentum, and due to the couple they come its on original position, then it is called as the stable. Now what happen in unstable equilibriums? If W and FB are equal, so W is equal to FB, here point B is below G. Earlier what happened? B is about to the G points. Okay, so in some cases that is a possible that the buoyancy force is below to the gravitational force. Okay, so such a body in which the buoyancy is below G, then it is the unstable body. So body is said to be unstable equilibrium as shown in this figure. So here we see this is the balloon, here the certain weights are there, this is the G point and this is the buoyancy force. So in the diagram what we see, the B is below to the G points. So here W is acting or a weight is acting in the downward directions, buoyancy force FB is acting in a upward directions. So if the slight angular displacement is given to the balloon in a clockwise direction, so here we also apply some angular momentum or angular displacement in a clockwise directions, then W and FB constitute a couple also acting in a clockwise direction. So how we can say it is also acting in clockwise directions? So here we see this is the upward, then this line, and from this line this W is also going in the downward directions. So here couple is created also in a clockwise directions. So here we give the angular momentum or angular displacement in clockwise direction. Couple is also created in the clockwise directions. The body is not come into this original positions. Now earlier in stable body, here we see that the couple is acting in anti-clockwise direction. So couple is acting from here, these cross lines and this FB. So it is come in the anti-clockwise directions. But in a case of the unstable body, it is also means couple is also acting in a clockwise directions, because here W is in the downward directions. Thus the balloon does not return to its original position and it is in a unstable equilibrium. Means in a unstable equilibrium means when we given some angular displacement to the body and body does not come to its original position, then it is called as the unstable equilibriums. And the third is the neutral equilibriums. So in a case of the neutral equilibrium, first the weight and the buoyant force F is equal. B and G are at the same points. So in earlier two cases, what we study in a stable equilibrium, the buoyancy point B is above G. In unstable equilibriums, the buoyancy point B is below to the G. And in neutral equilibrium, the B and G are at the same points. Okay, so B and G are at the same point as shown in the figure, then the body is said to be in a neutral equilibriums. Now here, more details are not given in a certain books, but during the neutral equilibrium, what happened? So in a neutral equilibrium is a state of equilibrium where body remains in its new position after being displaced instead of returning to its original position or moving away. Means when we give on to the small angular momentum or angular displacement to the body which have B and G are at the same place, then what happens? Body is displaced and reach to the new position instead of coming back to the its original position, then it is called as the neutral equilibriums. Now here we summarize what is the difference between the three conditions. So first, in stable equilibrium, the center of buoyancy B is above to the G. In unstable, the B point is below to the G. And in neutral equilibrium, both are at the same points. In all the three cases, we give some angular momentums or angular displacements. So in stable equilibrium, what happens? So when we given some angular displacement, the here anti-clockwise couple is created, and due to anti-clockwise couple, the body is come its the original position, then it is called as the stable equilibrium. In unstable equilibriums, when we apply some angular displacement, at that time the couple is also created in a clockwise directions. So here we provide angular displacement in clockwise direction. Couple is also created in a clockwise direction because here the G point is in upward to the buoyant force. Okay, and the body is not come to the its original position, then it is called as the unstable equilibrium. In neutral equilibrium, B and G are at the same points. Means when we give small angular displacement to the body and body is displaced and get the new position instead of coming to its original position, then it is called as the neutral equilibrium. Means in stable equilibrium, body comes to its original position. In unstable equilibrium, body does not come to its original position, and in neutral equilibrium, body is displaced and reach to the new positions. So thank you for watching this video. If you learned something, then like the video and subscribe my channel for watching the more video related to FMHM as well as other subject of mechanical engineering. For FMHM subject, various link is provided in descriptions, as well as in car. For other subject, I request to visit the playlist and don't forget to share with your friends.